In conductors, the current flows through due to electrons only. The current means not only electrons, positive charges also will move. The continuity equation we'll discuss now. What is meant by continuity equation? The energy will be converted from one form to another form. That is the continuation of energy. The charge also based on continuity equation. The continuity equation of current we'll discuss now. The current continuity equation, it is also called as the continuity equation in conductors and dielectrics, that is current continuity equation or current continuity equation. The continuity equation of the current is based on the principle of conservation of charge. Conservation of charge, it is based on the principle. The conservation of charge or continuity equation of current based on conservation of charge, principle of conservation of charge. The principle states that the charge neither be created nor be destroyed. The charges can neither be created nor be destroyed. It is based on conservation principle. Consider a closed surface. Yes, consider a closed surface. It is the S, and the current density J bar is normal to the surface area. Then the total current crossing the surface I. The total current crossing the surface I. Total current crossing the surface I. Already we saw that I equal to surface integral J dot ds. Surface integral J dot ds. The relation between current and J, make it as equation 1. The current flows through outwards from the closed surface only. It has been mentioned that earlier the current means the flow of positive charges. Hence the current I constitute due to outward flow of positive charges from closed surface. Yes. The current flows outwards. Current illa veltundi anukondi. Current flows through outwards. Assume that the current means the flow of positive charges. Hence the current I constitute due to outward flow of positive charges from the closed surface. Yes. According to the principle of conservation of charge, there must be decrease in equal amount of positive charge. Suppose the positive charge is moving outward, there must be decrease in equal amount of positive charge inside of the closed surface. Equal amount of positive charge will be decreased. This charge will be decreased. Equal amount of positive charge will be decreased. Equal amount of positive charge will be decreased inside of the closed surface. Hence, the outward rate of flow of positive charge gets balanced. Outward rate of flow of positive charge gets balanced by the rate of decrease of charge inside of the closed surface. Inside of the closed surface. ఒక కరెంట్ ఇలా మూవ్ అవుతున్నప్పుడు పాజిటివ్ ఛార్జ్ వెళ్తుంది అనుకోండి బయటకి. అజ్యూమ్ దట్ పాజిటివ్ ఛార్జ్ మీన్స్ current flow of electrons is nothing but current, but here assume that positive charge, whenever electrons are moving it gets positive. Due to the charge moving inside of the closed surface, let Qi, assume that Qi is the charge within the closed surface. Charge within the closed surface, the charge within the closed surface is Qi. Qi is the total charge within the closed surface minus dqi by dt is the rate of decrease of charge inside of the closed surface. Due to the movement of positive charges, what is the rate of decrease of charge inside of the closed surface? It is the rate of decrease of inside of the charge. Rate of decrease of charge inside of the surface. Minus indicates that it is a decrease in charge. The negative sign indicated here, it is that is the decrease in charge inside of the total surface. Due to the principle of conservation of charge, this rate of decrease is same as the rate of outward flow of charge. ఎంత ఛార్జ్ డిక్రీజ్ అయిందో అంత ఛార్జ్ బయటకు వెళ్తుందని అర్థమైంది కదా. డ్యూ టు ద ప్రిన్సిపల్ ఆఫ్ కన్జర్వేషన్ ఆఫ్ ఛార్జ్, ఎంత ఛార్జ్ సర్ఫేస్ టోటల్ సర్ఫేస్లో డిక్రీజ్ అయిందో మైనస్ dqi by dt, the same charge leaving the surface, the rate of decrease is same as the rate of outward flow of charge, which means a current. Which means a current it is. That is, therefore we can write I equal to surface integral j dot ds equal to minus dqi by dt. That we have to write here. That is, therefore we can write I equal to surface integral j dot ds bar. That equal to surface integral j dot ds bar equal to minus dqi by dt. Make it as equation number 2. Already we know that I equal to surface integral j dot ds, that equal to minus dqi by dt. This is the integral form of continuity equation. It is the integral form of continuity equation. The integral form of continuity equation is I equal to surface integral j dot ds equal to minus dqi by dt. How much charge is decreased? The decreased charge is outward current in a closed surface. This is the integral form of continuity equation. It is the integral form of continuity equation. Continuity equation of current. Current it is. Suppose in case of pipe, suppose if a tank is there, how much water is decreased inside of the tank? That is the flow of water inside of the pipe. That is the pipe continuity equation. That is transportation continuity equation. ఒక ట్యాంకులో ఎంత వాటర్ డిక్రీజ్ అయ్యో అన్ని వాటర్ పైప్లో వెళ్ళింటాయి. అదే కరెంట్ కంటిన్యూటీ ఈక్వేషన్, క్లోజ్డ్ సర్ఫేస్లో ఎంత కరెంట్ లీవ్ అయిందో, ఎంత ఛార్జ్ డిక్రీజ్ అయిందో అంత కరెంట్ లీవ్ అయినట్లు. దిస్ ఈజ్ ద ఇంటెగ్రల్ ఫార్మ్ ఆఫ్ continuity equation of current. The negative sign of this equation is indicates that outward flow of current from the closed surface. So the equation 2 indicating that outward flowing current, that is I. If the current is entering in the closed surface, then we have to indicate that it is positive sign. Therefore surface integral j dot ds equal to minus I equal to plus dqi by dt. The current is entering in the volume or surface, then surface integral j dot ds equal to minus I equal to plus dqi by dt. This sign will be reversed. The point form of continuity equation can be obtained from integral form. This is the integral form of continuity equation. I equal to surface integral j dot ds equal to minus dqi by dt. The point form of continuity equation can be obtained from the integral form using divergence theorem. What is divergence theorem? Divergence theorem is used to convert surface integral to volume integral. Divergence theorem is used to convert surface integral to volume integral. Already you know that. Now we are applying divergence theorem. Let us see. Now we are applying divergence theorem. According to divergence theorem, therefore surface integral j dot ds equal to volume integral del dot j var into dv. Here surface integral, it is volume integral. Now, therefore minus dqi by dt equal to volume integral del dot j dv. we can write from equation 2 and 1. Therefore, we can write del qi by dt, decrease in current, equal to decrease in charge, equal to volume integral del dot j dv. But qi is the volume integral rho v dv. That is qi equal to volume integral rho v dv we can write. But qi equal to volume integral rho v dv. Volume integral rho v dv. The current I equal to volume integral rho v dv we can write, where rho v is known as volume charge density. It is the volume charge density. If you integrate volume charge density with respect to v, then you will get qi. Therefore, we can write volume integral del dot j dv equal to minus d by dt of volume integral rho v dv. That equal to, we can write minus volume integral dou rho v by dou t dv. Can write like this. For a constant surface, the derivative becomes the partial derivative. For a constant surface, the derivative becomes partial derivative. Therefore, we can write volume integral, this one we can write volume integral del dot j dv equal to volume integral minus rho dou v by dou t minus dou rho v by dou t into dv we can write. If the relation is true for any volume, it must true for even for incremental delta v also. Incremental volume, that is delta v. Therefore, del dot j dv equal to, if the continuity equation, this relation is true for any volume, del dot j dv equal to volume integral minus dou rho v by dou t dv. If it is true for any volume, it must be true for even for incremental volume delta v also. Therefore, we can write del dot j delta v equal to minus rho dou v by dou t into delta v. Therefore, from this, if you compare this and this equation, del dot j equal to minus dou rho v by dou t, or if you cancel delta v in both sides, then del dot j equal to minus rho v by dou t. This is the point form of differential or point form. It is also known as point form or differential form of current continuity equation. Del dot j equal to minus dou rho v by dou t. Point form or differential form. It is also known as differential form of current continuity equation. The equation states that the current or the charge per second diverging from a small volume, the current or charge per second diverging from a small volume per unit volume is equal to time rate of decrease of charge per unit volume at every point. The current continuity equation states that the current or the charge per second delivering from a small volume or small surface is equal to the time rate of decrease of charge. The time rate of decrease of charge per unit volume at every point. ఎంత ఛార్జ్ బయటికి వెళ్తుందో అంత డిక్రీజ్ అయి ఉంటుంది సర్ఫేస్ లోపల. అదే కంటిన్యూటీ ఈక్వేషన్. For steady current, that is DC currents, if it is not for steady current, DC current means if it is steady means there is no changing with respect to time. Dou rho v by dou t becomes 0. For steady current which are not the function of time, dou rho v by dou t becomes 0. Del dot j, what will happen? Del dot j equal to 0 for steady current. For such current, the rate of flow of charge remains constant with time. The steady current have no source or sinks as it is a constant. Or understand this. For steady current, del dot j equal to 0. Again we will see what is current continuity equation from starting onwards. The continuity equation or current continuity equation can be described as the charge can be neither be created nor be destroyed. According to surface area, whatever be the charge leaving, the same amount of charge will be decreased inside of the surface. The total current passing through surface area with the current density J, then total current crossing the surface is given by I equal to surface integral J dot ds. Already we saw this equation. The current outward direction, it is current is outward, hence a small change in decrease in charge. Let Qi be the charge within the surface. In surface lo unde charge anukunte minus dqi by dt is the rate of decrease of charge. Minus indicates that due to decrease indicates in that minus. Due to the principle of conservation of charge, again the rate of decrease same as the rate of outward flow of charge, that is I equal to surface integral J dot ds equal to rate of decrease is equal to outward current, that is I equal to surface integral J dot ds equal to minus dqi by dt, minus dqi by dt we have to write. This is the integral form of continuity equation of current. What is the continuity equation? The amount of current which is passed through a conductor or leaving the surface is equal to same amount of charge will be decreased. If the charge is fully inside of the surface, the same amount of charge will be decreased. The negative sign indicates that outward flow of current from the closed surface. So the equation 2 indicating that outward flow of current. If it is current entering, suppose the current entering to the surface, we have to make it is a positive, that is surface integral J dot ds equal to minus I equal to current entering means we have to indicate minus I, that equal to plus dqi by dt. The point form of continuity equation can be obtained from integral form. It is the integral form of continuity equation, hence we are seeing the point form of continuity equation. By using divergence theorem, surface integral can be converted to volume integral by using del dot j dv. Here surface integral J dot ds equal to minus del dot j dv. After substituting that, the qi is the nothing but volume integral rho v dv, where rho v is known as charge density. After substituting this, volume integral del dot j dv equal to minus d by dt of volume integral rho v dv, we can write minus volume integral rho dou v by dou t, the partial differentiation we have to consider. For a constant surface, derivative becomes partial derivative, that is volume integral minus dou rho v by dou t equal to del dot j dv. If the relation is true, for a small element also it will be true, hence we can write del dot j equal to minus dou rho v by dou t. This is the point form of continuity equation or continuity equation in differential form. The express continuity equation in point form or differential form or integral form, like that they will ask the questions. For steady current, del dot J equal to becomes 0. Why? Because with respect to time, current will not change. Hence, del dot J equal to 0. For such current, the rate of flow of charge remains constant with time. This is about continuity equation or current continuity equation in a conductors or any closed surface.